into this here. All right. So first of all, thanks for joining us today. We're excited to be talking about these new sensor and motor training kits that we're offering. And my name is Mark Phillip, and I'm an application engineer with Studica Incorporated. And you can see my contact information if you need to get in touch with me for any reason, markp@studica.com, and you can see our website at www.studica.com. So yeah, today we're going to be looking at these new sensor and motor boards that we've developed for the NI LabVIEW in conjunction with the NI MyRio device. So we'll kind of be taking a look at what that's all about and showing you some demonstrations of it, and shouldn't take too long, so let's go ahead and get started here. All right, now the first thing is a little bit about us. Some people may not be familiar with who Studica is. We're a robotics manufacturer and distributor for education, among many other things. We're a global partner with World Skills International, particularly for the mobile robotics competition like World Skills Robotics, or also known as WSR. And kind of our motivation today is that we saw a need for something that teaches robotics and controls using LabVIEW and the MyRio. Both of those are very popular platforms that are used in this world. And the idea is that we wanted the program to be suitable for higher education as well as robotics competition teams that use LabVIEW, so things like World Skills Robotics, for instance, or First Robotics. So basically our product is going to be trying to train in the use of sensors, motors, and actuators. And the full product name, which is a bit of a mouthful, is the WSR Sensor and Motor Training Bundle for MyRio and LabVIEW. So what we see here is actually a picture on the right of the sensor board connected to the NI MyRio. So this is essentially what the sensor board looks like when it's connected to the NI MyRio. And then this would connect to your computer so you could interface with it using LabVIEW. So again, the motivation was that we noticed a need for some kind of tool that taught LabVIEW and control of sensors, motors, and actuators. And we're hoping that this kind of fills that niche. Now what's included in the kit is that pretty much what we see here. You get the sensor board as well as the motor board, which we'll be looking at a little more in depth later. And you also get Courseware with exercises in it, and we'll elaborate on the Courseware more down the line. And I want to point out that there's two different bundles. One of them includes the MyRio with LabVIEW, and the other one does not. So if you do not have a MyRio or LabVIEW, then if you're interested in this, you would want to get the bundle that does include those items. However, we do also have a bundle that does not include those. So if you do have a MyRio and LabVIEW and you're interested in this, you could just be getting the bundle that does not have MyRio and LabVIEW because you already have that stuff ready. However, there is a kind of caveat here with LabVIEW. If you have a student license, that's not going to cut it because this kit relies on the real-time module and the MyRio toolkit, which are not part of the student license of LabVIEW. So if you have a student version of LabVIEW, you're probably going to want to get the bundle that does include LabVIEW because the LabVIEW that comes with our bundle includes all those kits that you need. One last note here is that a university site license does have access to these different toolkits that you need. So if you have LabVIEW for the university site license, then you should be good to go. So we're first going to look at what's the sensor board, what's all on the sensor board. And again, we can see an image of it here. And you can see that there's quite a lot of different sensors we can work with. And the listing on the left here kind of goes through most of them. And so we have a 5-volt relay, which you see down here at the bottom left, SMD LED module, a capacitive touch sensor, which we see here. We have a toggle switch, which is kind of hard to see on the image, but over here, kind of on the middle right, there's a 2-way rocker with a digital input button, so you can push in on it to get a digital signal. Photoresistor, thermistor, IR sensor, ultrasonic sensor. There's a lot of stuff here. I'm not going to go through the whole list, but the idea is that we wanted to put as many sensors on here as we could to really allow people to experiment with controls and use it for potentially research, use it for robotics competitions, all sorts of different uses for the board. And so we wanted to be able to provide a wide range of utility on the board, essentially. And then we have the motor board that also comes in the kit. And the motor board, like it sounds, it focuses much more on the motor side of things rather than the sensors. So we have a stepper motor drive circuit, a hybrid stepper motor, a DC motor, a DC speed reduction motor, pulse width modulation controlled analog servo, a solenoid valve electromagnet drive, and a 7-segment LED display digital tube. So the idea with this board is that we're going to be getting a lot more work done with motors and you know, getting familiar with what the different types of motors do, how you interact with them, and kind of what their uses are, right, within the realm of robotics and controls. And again, the idea was to provide you with a wide array of options here so that it is a useful tool for either research or learning or doing, you know, competitions and things like that. So the bundle does come with Courseware, and the Courseware is quite expansive, and the idea is that it's supposed to be an introduction to using sensors, motors, and actuators with the LabVIEW and the MyRio. So we'll be using the boards, the sensor and motor boards in the Courseware to interface with the MyRio, which then interfaces with LabVIEW so that we can program it. The Courseware will provide detailed installation instructions from MyRio and the LabVIEW software. So it will basically guide you through the process of setting up everything from the hardware to the software and making sure you're up to speed with it. And it also provides a highly detailed introduction to LabVIEW as a programming language, or a graphical programming language, I should say. So you'll if you've never used LabVIEW before, you'll get quite an in-depth introduction to the terminology that's used, the UI, and kind of graphical programming in general. And lastly, it does draw parallels between, say, text-based programming and graphical programming. So if you do come from a background of like maybe working with Python or C or something like that, there is quite a bit of crossover as far as how that relates to graphical programming. So the first thing I'll look at is some of the Centerboard exercises. In the Courseware, you look at how do you read from analog sensors, how do you do digital input-output, how do you do pulse width modulation, how do you communicate with the serial port using the ITC bus, how do you use the SPI bus, orthogonal coding, and then there's some other modules that are included that I'm not talking about today. But the idea is to basically get you familiar with all the different sensors on the board and to kind of deep dive into these concepts in a more abstract way as well. So you'll talk about, you know, what is an analog signal? How is that different than digital? What is pulse width modulation? You know, what's a duty cycle? What's a frequency in pulse width modulation? What's the use of, you know, this kind of technology? So you're going to kind of get a broad spectrum of information about these different areas. So in the analog lab, some of the labs that you'll end up doing are graphing data from a photoresistor, and I'll kind of show a quick example of that here in a moment. And you'll do distance measurements using the IR rangefinder. You'll also be graphing temperature changes using a thermistor, and then you'll also manipulate the 2D rocker control to basically get an analog signal out of it. So on the photoresistor side, I'll go ahead and show an example of this, and I have tons of programs open right now. Whoops, that was the wrong VI. So I'm going to open up LabVIEW and open my photoresistor VI. And I'm not going to program it here just for the sake of time. I already have it programmed, but it's pretty simple, so I'll explain what this is doing. So people who maybe haven't seen LabVIEW, what we're looking at here is basically a program. And this square on the outside is a loop that will run whatever's inside of it until I press the stop button, which we see here on the front with this stop button. And then I have this waveform chart here, and this waveform chart has an analog signal coming from the sensor board, which is what this block here is doing. It's grabbing a pin from the sensor board and then sending it to the waveform chart to display that information here. And then this is just telling the program to wait 100 milliseconds between readings so that we can actually view the readings in a decent manner instead of getting way too many readings way too fast. And then this here is just for a error checking in case something went wrong with the MyRio. this will basically safely shut it down. So what I'm going to do real quick is turn on my camera, which was here. There we go. Okay, so what we have, sorry, I'm trying to focus my camera here. It's a little off. Okay, well, it's not wanting to focus, but so I have my Myrio right here, and then the sensor board here, and I have a photoresistor where my finger's pointing right here. Again, it's kind of hard to see because of the focus. But if I run my lab and I save it, what it's going to do is it's going to compile everything onto the Myrio, and then it will start running the program. And now it's running and we see data being graphed. And what it's graphing is basically the light intensity that's, hitting the photoresistor. So it's showing us resistance. And so if I kind of cover, again, kind of move my camera over. If I sort of cover the photoresistor from light, you see that the resistance goes up. And if I move my hand off, the resistance goes back down. So very simple look at how you can do analog data graphing in LabVIEW using the sensor board. And then photoresistors can be used for all sorts of further activities as well. So this is just a good way to kind of get you introduced to how do you use this board, how do you connect it to the Myrio, and then how can I actually grab a pin, from the Myrio and bring that into LabVIEW and graph that data. So then I can hit stop and the program is done running, and I'll go ahead and close that and pretty much move on from here. So after the analog labs, you'll go into digital input output, and again, the courseware will not just say, here's how you do this thing. It's going to also talk about, what is digital input output? Why is that useful? How does that differ from analog input, for instance? So you're going to look at controlling LEDs. You'll also do relay control, which we see down here at the bottom right is the relay, so that we can turn on some maybe higher powered object that's connected here. And then we have a TTP23 touch switch, which is this sensor here. So we press that with our finger and we'll basically turn an indicator on and off within LabVIEW, depending on how many times you press it basically. We have a toggle switch here that will turn on a series of LEDs. And then the rocker button experiment will take the same rocker from the analog lab, but utilize the digital input, which is when you push in on the button, you basically send a digital signal. So all these labs are going to look at doing digital I/O and basically how you can manipulate, get that data and then use it within LabVIEW. And then you'll move on to pulse width modulation. And again, the courseware will talk about what is pulse width modulation, why is this useful, and what are the specifics that you need to know about it. So you're going to be doing a 3-color LED experiment, which this is the 3-color LED here in the middle. And it's not lit up, but the idea is that you can send red, green, and blue values to it and manipulate this LED to show pretty much any color you want. And we see the RGB interface here on the right. You end up building something like this where you can raise and lower the values of the different channels to show a different color on the RGB LED here. You'll also do a passive buzzer experiment, and this is the buzzer at the bottom left. And this experiment was one of my favorites because you basically create like a kind of like a really simple musical keyboard, and when you press one of the keys, it sends a frequency to the buzzer, and basically that frequency vibrates on the buzzer, and you can actually hear, like 440 hertz come out of the buzzer. And that uses pulse width modulation to make that happen. So there's also a couple other labs that I don't have listed here, but these are some of the 2 big ones. So then you'll move on to the ITC labs and looking at what is the I2C bus, why is that useful, and like how does I2C work. And so you'll work with I2C by using a 9-axis gyroscope. You'll also do a digital light intensity sensor experiment and then a display control button recognition experiment. And I believe there's a few other ones in the works as well. But yeah, so you'll look at ITC and kind of get familiar with that and interfacing with that on the board as well. So that's just a few of the Centerboard experiments in the courseware. There's, not really enough time in the webinar to go through each and every one, but those are some of the big ones and the highlights. So we're going to move on and look at what the motorboard exercises are. So the main ones here are stepper motor, motion control, steering gear motion control, DC motor control, solenoid valve electromagnet control, and a digital tube display control. So you'll first look at stepper motors and basically manipulating them to go forward and reverse, looking at the rotation speed, or controlling the rotation speed, I should say, changing the rotation angle, and then doing acceleration, deceleration experiments. And again, with the courseware, it's going to talk about what is a stepper motor, how does this differ from, say, a DC motor, how do you interface with that when compared to like a DC motor or a servo. So there's a lot of technical aspects there as well, and a lot of learning to be had from the courseware on these topics. And then we also have a DC motor lab where you're going to look at making the DC motor go forward and reverse, and controlling the speed, detecting the speed, and doing the speed within an open loop and then a closed loop, and then doing motor position within a closed loop. And you'll also be using an encoder in this lab with PWM to basically monitor, I believe, is rotation. So with this lab, again, you're going to be looking at what is a DC motor and talking about how you interface with that. And yeah, there's a lot of good information here. And one of the fun things with this lab in particular is that you kind of go back into the pulse width modulation realm by utilizing the encoder. So I'll do a quick demonstration of this one. And again, I'm not going to program it, but I will show you the program and then show you it in action. So, but before I can do that, what I actually need to do is swap this board with the other board. So I'm going to go and unplug the power from the MyRio and make sure that the board has no power, and then basically remove these ribbon cables. And I have my motor board over here off camera. And this guy's a bit heavier. And then I can plug these back in. Power's still off. And I will plug in the power to the motor board directly. So since they are motors, I do plug in a separate power source. And I made sure that my switch here is set to off. And then if I turn that on, I now have power, and then I need to plug power back into the MyRio. And that should be good. So now let me open LabVIEW, and it's telling me that my target was lost, and that's because I disconnected the MyRio. So back in LabVIEW, I need to reconnect to it, and then that's going to take a second here. And the motor that we're going to be looking at is this guy right here. This is the DC motor. Let me see if I can focus. Doesn't want to focus. Okay. Still, I think the MyRio was booting up. Yeah, there we go. So I'm going to open up my DC motor VI, and a VI again in LabVIEW is basically a program. So let me set these back down to 0. So this is my front end. It's very simple. I have a field here showing me the motor count. So basically, like, how many rotations have I gone through, and it takes into account direction. And then I have a control here to manipulate the direction of the motor, and then a control to manipulate the speed of the motor. And if I look at my block diagram, this one has a bit more going on than the photoresistor. It's still relatively straightforward though. These two, let me highlight these two blocks here, as they call them. These are my PWM blocks. So one of these is going to a specific PWM pin, and the second one's going to a different PWM pin. One is controlling the speed and one is controlling the direction. And then the encoder here is basically sending out the rotation count to the counter field here on the front. So these two items, like the speed and direction, both correspond to these two controls here on the front. So as I manipulate these, it's going to be talking to the PWM pin on the board, which will then be, making the motor essentially do what I need it to do. And then this line here going to the MyRio node on the right is just basically an error check. So if I run to an error at any step of the way here, it's going to basically cascade through and safely shut down the program. So it's mostly just a safety precaution here that you take on the programming side. And then this is all wrapped inside of a loop that doesn't stop until I hit the stop button on the front. So if I run this, let me position my windows. I've only got so much real estate on my screen here, and it's hard to show everything. Okay, so I'm going to hit run, and it wants me to save, and then it's going to compile and send to the MyRio. And it's just a waiting process while this happens. Okay, there we go. Now, let me see if I can, I'm going to close that. Let me make this smaller. There we go. So now if I change the speed of the motor, you can see that it's starting to turn as I raise it. And I can bring it up to 1, which I believe is the maximum speed. So if I remember correctly, this is basically like 0 to 100%. And so if I bring it, say, 0.5 and then start changing the motor direction, what you'll notice is if I put the motor direction to 1, it starts turning, that would be clockwise for me. Looks, I believe, counterclockwise on the camera. If I put this back down to 0, we end up going counterclockwise from my perspective. And we see the motor count is basically counting the rotations, and it is taking into account like negative versus positive. So yeah, it's that's pretty much the DC motor lab. Pretty straightforward lab to implement, and gives you a lot of good information on interfacing with the motor board, as well as a lot of good information about DC motors in general. So I'm going to hit stop so that the program safely exits and my MyRio goes back to a safe state, and move on from there. All right, and then after the motor lab, one of the last labs you end up doing is basically taking all the different motors you've learned to interface with up to this point and put them all into one program. So you'll end up putting in your servo, the stepper motor, the electromagnet, I forget the name, the solenoid valve, and then DC motor and all that. So you put all that into one program, you end up making this front end interface so that you can basically control each motor individually. And yeah, you can have some fun with that one. So yeah, those are pretty much all the main motor exercises that we're looking at. And kind of the thing I want to emphasize is that with LabVIEW, really, you can make a lot of complex applications with the number of sensors and motors that we have here, because LabVIEW really provides you a very comprehensive language to actually manipulate all this. And so ultimately what it means is that this kit's a great tool for research, experimentation, and custom training, as well as even learning. You know, if people are maybe unfamiliar with sensors and motors or control solutions, this could be a really good way to introduce them. But it's also, I think, a complex enough kit that it can be used for actual research and data acquisition and analysis and things like that. So ultimately, there's a huge pool of potential projects that's really only limited by your creativity, you know? Yeah, so that's kind of the intent here. And the Courseware basically provides a good jumping off point to get you started with everything. So at that point, I'm pretty much going to wrap it up. And if anybody has any questions about anything, feel free to ask them. Again, everybody is muted, so I don't get feedback issues. But if you do have any questions, please use the chat feature. That is the second bubble on the left of your Join Me panel at the top of your screen. Looks like a little comic book dialogue bubble. If you click on that, you can send a message in the chat, and I'll do my best to answer the questions. So yeah, I'll wait for those to come in, and while I wait for those, I'll go ahead and point out some further information here. If you do need to contact us for any reason afterwards, maybe you're interested or maybe you have further questions, you can always reach us at sales@studica.com to speak to a sales rep, and our sales reps are really knowledgeable about these products as well. And they're also very experienced working with schools and education institutions regarding pricing and things like that. So if you have any questions there, feel free to contact us. You can also call us by phone, 888-561-7521, and we're available Monday through Friday, 9 a.m. to 5 p.m. Eastern Standard Time. I'm in Pacific Standard. It's Monday through Friday, 9 a.m. to 5 p.m. Eastern Standard. And then lastly, we will be sending a follow-up email that contains some extra information as well as a recording of this webinar. So if you want to show the recording to anybody or anything, feel free to do so. I'm not seeing any questions come in, so probably give it another 15 seconds or so, see if anybody has anything they want to ask. All right. Well, if you do think of any questions after the fact, feel free to reach out to us, let us know. And other than that, look out for the email that we'll be sending with the follow-up. And hope you all have a good day and a good rest of the week. Thank you for joining us.